Welcome to the lesson on section 4.10, the antiderivative. In this lesson, you'll learn about the definition of an antiderivative and how to solve an initial value problem. The antiderivative of f is the function that has f as its derivative. In our first example, consider the function f of x equals 6x squared minus 8x plus 3. We'll find an antiderivative, capital F, such that the derivative of capital F is the given function, and capital F of 0 equals 2. A formula for a function capital F that could have our given function as its derivative is 2x to the third minus 4x squared plus 3x plus a constant. Remember that when we take the derivative, this constant will drop out. We're saying that y equals 2x to the third minus 4x squared plus 3x, or any graph parallel to it, can have lowercase f as its derivative. This is called an initial value problem because we're given a point on the graph of the antiderivative. Because of this point, we can find the value of the constant c. So since f of 0 equals 2, we can plug in 0 for x and 2 for f of x and solve for c. That makes c equal 2, so our derivative is 2x to the third minus 4x squared plus 3x plus 2. In our second example, let's find an antiderivative for x squared plus sine of x, such that f of 0 equals 4. First, write a formula whose derivative could be the given function. You can check this by actually taking the derivative. In my answer, the derivative of 1/3 x to the third would be 3 times 1/3 x squared, which is x squared. The derivative of negative cosine is sine, and the derivative of the constant would be 0. Since we're given that f of 0 equals 4, plug in 0 for x and 4 for f of x. Solving for c, we get c equals 5. It's very common for students to assume that f of 0 equals 4 implies that the constant will be 4. Note that this is not the case. That makes our derivative 1/3 x to the third minus cosine x plus 5. This concludes our lesson on section 4.10, the antiderivative.